All right, so hopefully you've all kind of got a handle on how to deal with mirrors and how to create objects and images in the different types of mirrors: concave, convex, in front of the focal point, behind the focal point, in front of the center of curvature, behind the center of curvature, and how to work with that. The equations associated with this are in your notes, but right now we're looking at how to actually understand what is happening as opposed to just using equations to figure out object height and all that other stuff. Okay, so let's look at lenses. Now we learned about the laws of refraction, and when a light goes from one medium, in this case air, into another, in this case probably glass or plastic or some other type of polymer, that the light, unless it's completely normal to the surface, it is going to be refracted, and so the angle of incidence is going to change with the angle of refraction. Now, the great thing about lenses is that you can kind of assume a couple of simple situations. Just like in mirrors, lenses have focal points. Now, what that means is that a line that moves parallel to the axis of the lens, when it goes through the lens, it then gets focused onto it gets focused through what's known as the focal point, G in this case. Now, what's really happening is not actually that the light goes in a straight line and then all of a sudden it decides to make a X degree turn and then go straight into G. That obviously doesn't make any sense. Because it's supposed to refract at this point here and at this point here. So what actually happens is that there's two stages of refraction, and I'll just draw a couple of line segments. One that kind of goes like right to here, and then another that goes like right to here, and then another that goes like right to here. That's kind of what happens. Although not exactly. I think it probably looks a little bit more like that more than anything. But it's not exactly important what's happening at the kind of the detailed level inside the lens. We're more worried about where the light rays are going in general, or where they end up once they pass through the lens. So as a simplification, we're just going to say that a parallel ray of light to the x-axis is then going to get focused through the focus here. Okay. Similarly, a ray of light that goes through the focus is then going to get refracted to the to become parallel with the x-axis, and that's what you can see right here. What you've seen is that I now have two rays of light, one that goes to the focus, just like in mirrors, and one that goes parallel to the axis of the mirror or of the lens. And what happens is both of them get focused down, and the place that they intersect is again where the object is going to be formed. And so you can see that I've created this vector v here, and that is the place of the image formed. Again, because I have real rays of light being focused to one point. Notice this isn't like mirrors. This is a lens. Now that they've been focused to one point, this makes it so that this is actually not a virtual image, but a real image, because this ray of light on this side of the lens is actually real as opposed to what an eyeball is extrapolating. So what I've created here is a vector v, or an image that is real because the rays of light are actually being focused. Now what I want you to do is I want you to take this, this vector and look at your worksheet. Use your worksheet to draw the rays of light associated with it, and also draw another ray of light, or another ray that is associated with this u here, or with this vector that it's now behind twice the focal distance, or this is kind of the center of curvature of these lenses as well. So I'll give you a few minutes, spend about 5 minutes to do this, to check out what the image you're going to form looks like. Okay, Now that you've checked that out, make sure that it in fact looks like what it's supposed to look like, which is 1, 2, 3, 4, and then therefore it creates an image here. This is also a real image. However, this image is shrunk in comparison to this image, which is larger than the original object. So you can see that depending on which side of the center I am, or twice the focal distance, I am going to create an image that is either larger or smaller than my original object. Now what I want you to do is I want you to think about very, very hard what is going to happen when I'm in front of the focal distance. Because again, just like with mirrors, what happens is as I approach the focal distance, this object gets larger and larger and larger and larger and larger, and it doesn't matter how much I zoom out, it gets larger and larger and larger until eventually it gets so huge that it effectively disappears. So what do you think is going to happen once I move past the focal point? And it's going to be similar to what happened in the mirror case. Did you say virtual image? Because that is the right answer. What happens in this case is that because the lines are now diverging once I pass the focal point, remember these are actual rays of light right here and another ray of light right here on the other side of the lens. These two rays of light are diverging, and so therefore on the opposite side they are going to be converging. So if I put an eyeball here, I'm going to put another creepy eyeball. If I put an eyeball there, it follows along this line and it thinks that there's a image here, even though the line is being refracted to this point here. And similarly, another eyeball right here that looks along this line is going to end up getting refracted to the original object, but it thinks that the virtual image is, or the actual object is over here, and that's why we call it a virtual image, because the rays are diverging, and so they converge the followed through rays converge on the other side of the lens. So when the rays converge on the same side of the lens as the object, you're going to get a virtual image. And again, you can see that in this case, these concave lenses are always creating a virtual image that is larger than the original object itself. Unlike a concave mirror, which had always created a smaller object than itself. Okay, so that is it for the crash course on mirrors and lenses. And so you should go through your worksheets as well as your labs to explore the nature of this refraction and how you can create images, both virtual and real images, and how they are related to the position of the original object that you've created.